Alright, so we have our sum and difference formulas. We looked at all of these. Notice for each one, the only difference between the sum or difference is the sign.
Return from Mars.
So,
Yeah.
that's the only thing. The sines and cosines, all of those, and the tangents over here, they're the same between our sum formula and our difference formula. The difference is in the signs, okay? So these wouldn't be too terrible to memorize, but again, I'm not going to have you memorize them. I do want to, however, practice using them, okay? Now, earlier we said that two angles that we could add together from the unit circle that to get an angle that wasn't on the unit circle was 30 and 45. Okay, and 30 and 45 give us 70. Alright, so we're going to use our formula to actually find the value, the exact value of the cosine of 75. So here's our formula. We have cosine of u plus v. And if I'm doing the cosine of u plus v to get cosine of 75, what two angles am I going to be adding?
45 and 30.
Yeah, 45 and 30. Does it matter which order we put them in?
No.
No. Okay. So 45 plus 30, okay, will give us 75. So let's then use our formula, okay? We're going to take the cosine of 45 times the cosine of 30 minus the sine of 45 times the sine of 30. Alright, so u and v are 45 and 30, so we write it out with our formula. Now we just need to use our unit circle to figure out what all of these are, okay? And you guys should be able to do that. What's the cosine of 45?
Root 2 over 2.
Root 2 over 2. What's the cosine of 30?
Root 3 over 2.
There we go, root 3 over 2. Alright, so we have that minus, what's the sine of 45?
Root 2 over 2.
Yeah, root 2 over 2. And the sine of 30?
1/2.
A half. Okay? So you'll notice both of these fractions are going to have a denominator of 4. So my numerator is going to be root 6 minus root 2. And that's root 4, right?
No.
No.
Kidding.
No.
Kidding.
I know. Alright, so that's all we can do here. Okay? Root 6 minus root 2 over 4. That's as simple as it can get. And that would be the exact value of the cosine of 75. Okay?
That's cool.
Yeah. And then obviously now we could find the 105 if we did 30 and 75, right? We'd have to figure out what the sine of 75 is first, but you can see kind of how these will build, and we can kind of develop a whole table of different angles. Yes?
So I get how those two are added together to get 75, but when would you use like when they subtract?
Well,
Like would it be like the exact value of cosine 30 and then it'd be like 75 minus 45?
you could, but since 30 is already on our unit circle, we wouldn't do that. However, we could do 45 minus 30, and that would give us the cosine of
Oh, 50.
15. Okay? So, and in fact, let's take a look at one where we do have to use subtraction. Okay? Find the exact value of sine of pi over 12. Okay? This one's a little tougher to recognize what the two angles would have to be, but I'll tell you it is subtraction. What two angles would we subtract to get pi over 12? Tristan?
45 and 30. No.
Well, we're in radians here.
Oh, right.
Oh, right.
Pi over
Pi over
4.
4 minus pi over
I'm
6.
getting there.
Pi over 4 minus pi over
What about pi over
6.
4 minus pi over 3?
Pi over 4 minus pi over 3.
Pi over
Okay.
pi over 3 minus pi over 4.
Yeah, there we
Oh,
go.
yeah.
Yeah,
There we go.
Yeah, there we go.
And it takes a little bit of doing, but we can figure it out here. So that's good. Sine of pi over 3 is bigger because a third is bigger than a fourth, right? So pi over 3 minus pi over 4, right? And you can double check because pi over 3 would be 4/12 pi, and pi over 4 is 3/4 pi, or 3/12 pi. If I subtract those, I get pi over 12, 1 pi over 12. Okay? Yeah.
With pi over. You can go. So.
Is there like a quicker way to figure it out? Is there like a method to like figuring out what's going on?
Well, what I would do, I would think through what my denominator is. It's 12. So I'm either going to combine one of the angles that's over 3 with the one that's over 4, or I would have to combine one that's over 2 with one that's over 6. Okay, to get a common denominator of 12. Now I would avoid this one because while 12 is a common denominator, it's not the least common denominator. It's 6 and 2. So there will be a better way, and that's kind of what would lead me to doing something with pi over 3 and pi over 4. Then it's just a matter of figuring out what your numerator is.
Okay.
So radians are a little bit trickier to figure out, but if you think in terms of the common denominator, that'll help.
Would pi over 4 minus pi over 6 work too?
Yeah,
Pi over 4 minus pi over 6.
yeah, it works.
Let's try it. Pi over 4 minus pi over 6.
So what's the problem?
Pi over 4 is the same as 3 pi over 12. And pi over 6 is how many pi over 12? 2, right?
So what's the problem with that?
There is no problem with that.
Yeah.
That would work. Okay?
I was just wondering.
Yeah, it'll work. And in fact, you could actually verify that you're getting the right thing if you did it both ways.
We don't
You know?
have to do it both ways. Okay.
It wouldn't be too hard. So. That's the nice thing about it. There's more than one way to do a lot of these. Okay? But for our sake, let's go ahead and just do this one. Alright? We're going to use u would be pi over 3, v would be pi over 4. Okay? So try to take those, plug it into the formula, and get your answer. See what you can do. We're already in radians.
So, I sign that, how would you do with that?
Mhm.
Do you have to use an identity with this one because you sine and cosine?
You actually don't, because we can get all of these from our unit circle. Okay? And we're using an identity to get all of this, but now we have it all in terms of things that we know. Okay? Right? So, what is sine of pi over 3?
3 pi over 2. Wait, square root of 3 over 2.
Yeah, root 3 over 2.
Or 2 over 2.
Cosine of pi over 4 is root 2 over 2. Okay? And minus, what's cosine of pi over 3?
1/2. 3 over 2. Nope. 3 over 2. 1/2.
Yeah, 1/2.
Or 2
And-
over 2.
Root 2/2.
I got the exact same thing.
Yeah,
Okay.
same thing.
You got the same thing?
That's the
Yeah.
same.
Their co-function identity.
Yeah.
Actually, it is.
Okay.
What did you say this was in degrees? Somebody said it. It's 15. 15 and 75 add up to
90.
90. So it actually makes
Oh.
sense that the sine of 15 or pi over 12 is the same as the cosine of 75. Right? Cofunction identities. Glad you guys saw that. Okay? Now, we're not always going to get root 6 minus root 2 over 4.
That's so sad.
But-
Can that be every answer? Great.
Can it?
That would make things a little too easy.
No.
No.
Alright, so anyone have a question on these? Really, the key is just figuring out which two angles combine to make the angle we want to find. Okay?
So, like, if on the test you would just say put that, let's say, and then we'd have to find.
You'd have to figure out the two angles.
And that's,
And
okay.
the thing is, if you had done this, with pi over 3, pi over 4, that would work. If you had done pi over 4 and pi over 6, that would work. You could have done, let's see, you could have done, let's see. You could have done 5 pi over 4 minus 5 pi over 6. Okay? That would have worked too. But you'd probably be able to get something in the first quadrant that'll work when you're doing the subtraction. Okay? Any other questions? Alright. Let's take another step here. We want to find the value of sine of u plus v for this situation. Okay? The sine of u is 4/5, and it says u is between 0 and pi over 2. What does that mean?
It's in the first quadrant.
Yeah, first quadrant. I'd put a little Roman numeral 1 there just to make sure we remember that it's first quadrant. Okay? And then it says the cosine of v is negative 12/13, where v is between pi over 2 and pi. So where are we there?
The second.
Second quadrant. Good. Second quadrant. So when we're looking at our formula, this first part we've got, right? We've got that no problem, because sine of u we already know is 4/5, and cosine of v we already know is a negative 12/13. But now we need to get cosine of u. We don't know. And we need sine of v, and we don't know that either.
Yeah, we could do that in geometry.
So what do?
Just we got two triangles. You know.
Okay, we'll keep going with that.
Yeah.
We've got a triangle, right?
Yeah, and since sine of u is 4/5, so yeah, so that is 5,
So this is 5.
and that's 4, and
Good.
that's 3.
Yeah, okay.
And cosine of v is negative 12/13, so so that is 13, and that is 12, and the other side is 5.
Good. Okay. You guys know your Pythagorean triples?
Excuse the interruption. All residential prefix must report to room 111 right after school. Thank you.
She gives the script
Alright.
this time.
So, we have two right triangles. This was similar to your quiz, where I gave you some information. I gave you one trig function, and you had to find the other 5. Okay? Similar idea. This was one way you could have done it. Draw a triangle. Fill in what you know. I know that the sine is 4/5, so the opposite is 4, the adjacent's 5. I use the Pythagorean theorem and I can figure out that my other side is 3. Okay, so now I needed the cosine of u. What is the cosine of u now?
3 over 5.
3 over 5. Okay, so I can plug that in. Whoa,
Uh-oh.
let's make that a little smaller. There we go. So that's 3/5. Okay. Over here, oh, by the way, we're in first quadrant, so I know it has to be positive 3/5. Right? In the second quadrant, I'm trying to find sine. So is that going to be positive or negative?
Positive.
Positive, second quadrant. That's significant that they told us that, alright, for that reason. How do we know if it's positive or negative? But now we know that the sine of v is what?
5 over 13.
5 over 13. Okay, so now we can plug that in. And now we can evaluate and figure it out, okay? These both end up being over 65, or, yeah, 65.
Negative 33.
Negative 48 plus 15 is a negative
33.
33 65ths. Okay, that's the sine of u plus v. Okay.
Yay.
So, does that make sense? Pretty much? Alright. So, tomorrow we're going to pick up here. It's actually kind of an interesting one. I'll just introduce here. It says we want to write cosine of the arctangent of 1 plus the arc cosine of x as an algebraic expression. Okay? Well, what is u?
Arctangent of what?
Arctangent of 1. I thought u was supposed to be an angle. Is that an angle?
No.
Oh, yes.
Yeah,
Yeah,
right? The
yeah.
arc function gives us an angle, right?
Yeah.
Yes.
What is the arctangent of 1?
Pi over 4.
Yeah, pi over 4. How
Wait,
about that?
Did you figure that out because you put it in the calculator? Or is
Well, no. Remember our unit circle, tangent, sine over cosine. So where are sine and cosine the same thing? At pi over 4. Okay?
Or 5 pi over 4.
Or 5 pi over 4. Because they specifically gave us arctangent, we'll just stick with the first quadrant because the range of arctangent is negative pi over 2 to pi over 2. So we'll just keep with that one. What is v?
Arc cosine of it.
Arc cosine of x. This one takes a little bit of working. Okay? This means that v, I'm sorry, the arc cosine of x, that means that whatever angle v is, the cosine of v equals x, right?
Yeah.
So I could see that as x over 1, would you agree? This one takes a little bit of a trick to, or some deeper thinking to figure out. Okay? If I see that as that, I can actually draw a triangle, put v here, my hypotenuse would be 1, and this side here would be x. Which means I could use the Pythagorean theorem to figure out the other side.
But wouldn't one of them just be x?
Yeah, this is x.
Yeah, but like if you use the Pythagorean theorem, you're gonna end up with like, oh, never mind.
we would do x squared plus whatever this is squared equals 1. So you'd have 1 minus the x squared, right? And then you'd have to square root it. So that's how we could express that side. Alright, we'll pick up there tomorrow.
Low battery.
Finish that off and look at some other stuff with those.
Low battery.
Here's the deal.
Honey,
On the
low
homework, I gave you some where you were practicing using it.
Oh,
Some of the later stuff you won't necessarily be able to do yet, but try a little bit of the beginning stuff for homework. Alright? Alright, have a great day.